So today we will go over functions. This is a brief introduction and I will quickly go over what they are, how they work, and how to combine them. So to start things off, what is a function? A function is a rule that takes each input value and assigns it to exactly one output value. You can think of it as a machine where it drops a number in and exactly one number comes out, never two. So what this means is that you're given some input x, you put it into this, what we call the machine. This f is what we call the machine, and it outputs some number or some output f of x. And what I meant by every input has only one output, it means that given this set of numbers, for example, 1, 2, 2, 4, 3, 6, this is a function because this first number corresponds to the first input and this second number corresponds to the output. And what this squiggly line means is that it's a set. And that pretty much means that you're applying these pairs of numbers with the same machine or the same function. So 1 is the input, you put it through the function f, the number 2 comes out. You put the number 2 as an input into the function f, and the number 4 comes out, so on and so forth. What isn't a function is when one input maps to two outputs. So how would that look as a set? This is not a function because we see that the number 1 maps to two outputs 2 and 4. Hence, this breaks the rule of a function, and this means that this is not a function. A lot of times, function is written as f of n, or just like the letters f and n. So, expanding this even further, how would this look in a graph if it means that one output must only map to one, or one input must map to only one output? So given some xy coordinate, something like x squared, like a parabola, is a function. Because if you do the vertical line test, it doesn't matter what point you do the vertical line, there's always only going to be one point where there's only one point of the graph it is touching, not two. So let's give you an example of what it will look like if there were multiple outputs. So a graph with multiple outputs could look something like this, where there's like a weird squiggly line thing. Over here, there's only one output, which does pass the test. But if you take a look over here, this line over here has 3 outputs. Let's say this x is 1. This at x equals to 1, it could equal to y equals to 0, for example, y equals to 2, y equals to 3, for example. And that doesn't qualify as a function. So now that you understand what a function is, I can go a bit more into detail of function notation. So we say this f bracket x bracket, or f x in the brackets, is read as f of x. It doesn't mean f times x, it just means that the output of function f when the input is x. So I'll give you some very simple ideas just to show you how to apply this function. So for example, if f of x equals to 2x plus 3, find f of 4. So how would you solve this? Since we know that this 4 corresponds to x, it's just, you can think of it as a placeholder. This x is a placeholder, And given some question f of 4, you just want to replace every variable, what variable you set here, with every variable you set in here. So it would look something like 2 times 4 plus 3, and then you find your answer. Just to reiterate on the whole, this 4 replacing every placeholder variable, let's say you have some function f of x equals to 2x plus 3 plus y squared. And you want to find f of 4. What you wouldn't do, you wouldn't just plug in 4 randomly into the x, and you wouldn't plug it randomly into the y. You would only plug in the 4 into the x, and you would get something like 2 times 4 plus 3 plus y squared. You wouldn't plug in the x placeholder into the y since it is a completely different variable. And yeah, that's just a really brief overview of function notation. Next, we'll go over domain and range. And the range is all the possible outputs a function can produce, aka the y values. And this concept is pretty simple. Again, given some coordinate, some xy Cartesian plane, given some random graph you have, something like this, I'd say. The domain is all the allowed inputs for the x values. So it is, let's say the graph stops here. This is the range, this is like the size of our graph. The domain is all the x values. So all that means is that going down from here, let's say x is, I don't know, 3, -4. The domain is pretty much the space that the x values occupy. So in this case, x would be -4 to 3. Because the graph is encompassed within this -4 to 3. And range, again, similarly, it is the space that the y dimension encapsulates. So in this case, it'd be something like here and something like here. So let's just say this is 2, this is -2. So the range would fall within -2 to 2. Since there is a real point in the graph anywhere between this 2 and -2 range. There's a list of common function families that I think you're probably familiar with, like linear, quadratic, cubic, exponential, square root, and if you have any questions, you can just email me about them, and I can go into a little bit more detail as to like how you can identify a simple graph. Like what I mean by that is like, could you identify a graph that looks something like this? Would you know that it is a, like this, just having this form, could you recognize that this graph is in the form f of x equals to root x? And I think just understanding these trends could help you in future problems, but again, I don't want to go too much in detail of this. Something like this could be, read would be like f of x equals to some exponential function a to the x or something like that. I'll give you a bit of a brief overview on operations on functions. So it's just like, how do you add, subtract, multiply, divide outputs? So the 4 operations for addition, given some function f plus g of x equals to f of x plus g of x. Subtraction, again really similar, f minus g of x equals to f of x minus g of x, and multiplication, division, also all pretty similar. Again, you have f times g equals to f of x times g of x. And then again, division. The only key thing you need to know about division is just that g cannot equal to 0 because you cannot divide by 0. F of x over g of x. And note that g of x cannot equal to 0. Now we're going to go into something a little bit trickier and an area where a lot of students kind of struggle with, which is called composite functions. Composite functions is something where you're combining functions and you can think of it as like a system of machines where before system A can finish a task, it must input something from system B. And I'll show you that in writing. So the way you would say this is g of f of x equals to g f of x. G of f of x. And that pretty much, it's not too difficult. It sounds pretty complex, but again, all you're doing, if you think of to that machine analogy, you have some input x, you're feeding it into a function f. You're getting some output f of x. But what if you feed this f of x into another machine called g? Then you would get some output called g of f of x. I hope you can see how the input is what becomes within the brackets, g of something, and that something is that input. As you can see here, this entire f of x term is within the brackets of the machine g. And another thing to know is that order matters. So g of f does not equal to f of g. And we'll go over some examples to show you why that is not the case. So let's let f of x equals to x plus 2 and g of x equals to x squared. So let's solve g of f of x equals to g, because f of x equals to x plus 2, we'll put that in brackets, x plus 2. And because g of x, we're replacing this entire term and putting it into the x. So we would have x plus 2 squared. And this is our expression for g of f of x. Now, what if we do f of g of x? How would that look? So we can replace g of x with x squared, so we would get f with x squared in the brackets. And again, f of x equals to x plus 2. So you would put this x squared into the x. You would replace all the x's in this equation if there were more. And that would look something like x squared plus 2. And this is your answer for f of g of x. Lastly, we have something called inverse functions, and this is where it gets pretty confusing. The inverse is written as f with a -1, kind of in the exponent form, or in the exponent position, and the inverse undoes what f did, and together they cancel out. So how would I show that they cancel out? So let's say I take f of inverse of f of x, and this is just equal to x because these cancel out. Same way if I do the inverse of f of x, it also equals x because again these two cancel out. I hope this kind of makes sense. If this doesn't make sense, I can try to explain it in a different manner. But if I'll show you an example of how to find it, and hopefully this idea kind of makes sense to you. But inverse functions is a really difficult concept to understand, and it's kind of hard because they're kind of reverse engineering how to get the original equation, if that makes sense. So an example would be, write y equals to f of x. Step 1. Step 2, swap x and y. Step 3, solve for y. And I'll show you how to apply these steps. So given some function f of x equals to 2x minus 6, for example. So the first step, write y equals to f of x. So we have f of x. Step 2, we would swap x and y. So we would get 2y minus 6. Now, all we need to do is solve for y. Sorry, I missed. Because, just to reiterate, f of x is often written as f of x and y are interchangeable most of the time. Yeah, just understand that for now, and we'll move on from there. So again, you can just think of this as y, so we're swapping x and y. That's kind of what I meant by that. Sorry if I didn't. Sorry for the confusion. Okay, so now on to step 3. Solve for y. And I would add 6 to the right side and divide by everything by 2. So I would get x plus 6 all over 2. And that would equal to the inverse of f of x. I hope this makes sense. I'll give you a list of practice questions, or I'll include my email in the bottom of the video, and you can email me there, as I often check my email a lot more. And yeah, I'll add the questions in the description as well.